Okay, so I have put together this video to help answer a question that was asked recently, which is how to measure a streaked object. So what you've done is you've taken a set of exposures that are too long in duration for the speed of the object. And as a result, that object has produced a trail or a streak in the images. So what we're looking at today is 2009 PQ1, that's the object, and 4 images were taken of this object. They are each 2 minutes in duration, or 120 seconds, and at the time that these images were taken, the object was moving at a speed of 8 arc seconds per minute. And so if we go ahead and load these up into the image viewer, then we can see that the object is indeed streaked. So here's the object on the first image, and here's the object on the second image, the third over here, and then the fourth image over here. So this is definitely a streaked object, which is not surprising considering that these are long exposures for the speed of the object. So my first response to that question is simply try to avoid streaked objects to begin with. And of course the way you do that is you take shorter exposures and also more of them. You take more of them in order to regain that signal-to-noise ratio that you would otherwise have with a longer exposure. So as an example, I might take 30 exposures, or I might take 60 exposures, perhaps even more. It just depends. But I would take at least 30 exposures. And as far as the exposure duration itself, well, you can kind of get a starting idea of that if you use a calculator. So if you go to Tools, there's a calculator here, Calculate Optimal Exposure Time. And there's a lot of information here, but basically down at the bottom, there are 2 inputs here. So the first of which is the plate scale. So these images have a plate scale of 0.55 arc seconds per pixel. So 0.55 arc seconds per pixel. That's actually pretty oversampled, all things considered. So if you're oversampled, you're going to increase the chances of the object producing a streak. So anyway, that's what it is. So you type in the plate scale, and then over here you type in the speed of the object. So it's moving at 8 arc seconds per minute, and so I type in 8 here. And then once you've done that, you click Show Optimal Exposure Time, and that's going to highlight the row that matches those parameters. So here it says exposure time of 4 seconds. So it says that that would correspond to a streak of 1 pixel, which basically isn't really a streak. It just means that the object would move 1 pixel every 4-second exposure. Now, these numbers are just theoretical. They don't really know anything about the atmospheric conditions and that sort of thing. So you can use that as a starting point. So you might even do an 8-second exposure, which in theory would produce a 2-pixel streak, which would be fine. But certainly that's a lot shorter exposure than 120 seconds. So that's the idea, is to try to avoid a streaked object in the first place. And what you do, again, is you would take lots of these shorter exposures. So you would take 30, maybe 60 of them. And you'd also do that depending on your goal, but you would try to take maybe multiple sets of them throughout the night. So if your goal is to produce useful astrometry measurements, to have a sufficient arc of measurements throughout the night, then you would have a 30 exposure set, and then another one maybe 20 minutes later, and so forth. These are really short exposures, so there's no reason not to have at least 30 of them. And so anyway, I'm not going to go into a whole lot of detail on that. That's kind of standard practice for doing NEO follow-up. But again, back to the question of how would you generate good measurements of this object? So certainly anybody can point to it and say, here it is, but that's not going to give you a useful astrometry. So what I would probably do, actually what I like to do to start off with, is I like to go to Tools, Download Observations. I like to kind of see what I'm working with. So I would type in the object name, the designation, and this is a confirmed object. So you choose that option and then you click OK. And what this allows me to do is I can look at all the observations and then I can view them in the Find Orb software. So I pull up Find Orb and it's going to compute the orbit of the object, and it also shows me the residuals of each measurement. And what I'm doing here is measurements of this object were actually already submitted using these images several months ago. So this is kind of a follow-up to that. Basically the question was, how would they improve upon that? So the original measurements, as you can see here, have very high residuals. So 5 arc seconds, 2.3, 7, 6.5. So these are very high errors in the measurements. So even though this is a streaked object, I think we can do better than that. So what I'm going to do is I'm just going to click on the object in the first image. I'm going to say create marker 1, and then I'm going to go to the last image, find the object again. And again, I'm just kind of doing this manually. So I already know about the object, so I'm just doing it this way. There are lots of other ways to do it. You could attach ephemeris to the data set, and using that ephemeris information you could create a stack from it and so forth. But this is just easy enough. I'm going to then create a track from those marker positions. So what I've done is I've told it, here's where the object is on the first image, here's where it is on the last, and that therefore it can create a track from those markers. So that's what I've done. And so if I double click on the track, then it says it can allow me to verify it. So what we're looking at here is an animation of the object. Anyway, by default this is going to limit you to 3 observations, and it does that just because it's going to assume that you want to create stacked observations. You want to create observations derived from stacks. And so normally you would just create 3 observations, but here if we want to create more, you go into photometry mode, and that's going to allow you to create as many observations as there are images. So we have 4 images, so we can create 4 observations. Anyway, again, this is 2009 PQ1. Alright, so what we've done now is we've created 4 observations, and these are not going to be very good observations by default because it is a streaked object. And so Tycho doesn't really know anything about a streaked object. It just it works using a point spread function. So it assumes that the object is, like I said earlier, you've basically taken a short enough exposure that it does not produce a streak. But in the event that you do, and that's what you have to work with, then you can manually intervene and help it out. So again, the green crosshairs indicate where the centroid was computed. So if we want to look just right off the bat, how do these observations look? Then we can view with the existing, and I like to remove the original observations for comparison purposes. So that's what I'm going to do here. So take out the 4 original observations. So we have a 1.3, a 1.0, 1.6, and then a 1.2. So these are still unacceptably high. So I'm not sure if we'll be able to do much better than that, just because, again, it's a streaked object. You don't have a point spread function, PSF fitting to work with, and so forth, that you can use for accurate centroid computation. But if I go ahead and right-click on that observation, I can modify it. So what I can do there is I can create a ruler. So I can give it a start and stop point, and I can go to the midpoint, and then I can say recalculate using current pixel position. So as you can see, that has moved the centroid, and I can do that for the other observations here. So I create a ruler, and even for me it's kind of hard to tell where the start and stop of the streak is. It's a bit ambiguous. So that's why I say it's much better to try to avoid streaked objects to begin with. Okay, now the last observation here. Alright, so now that we've updated the observations, let's go ahead and see if we've improved from what we had before. So as I did previously, I'm going to remove the original observations and then see how these new observations perform. Okay, so we have a 0.75 and the first one, a 0.37, a 0.71, and a 0.69. So all four of these observations are now under 1 arcsecond in residual, so I would consider these to be good measurements. And so, you know, in the future, if you had to work with a streaked object, this is how you would do it. You would manually intervene, and you would tell Tycho where the start and stop of the streak is, and you'd go to the midpoint and so forth. So that's how you have to do it. Streaked objects are simply going to be more of a challenge than otherwise. But anyway, hopefully this answers the question. So thanks for watching, and see you next time.